happy that you're here, that you found it, and are sharing this presentation on interoperability behind the meter. And we're talking about energy management systems today. Who is we? Well, that's Nicolas, co-founder and CEO of Seita Energy, and they are actually building an EMS. You will talk about that later more, I guess. I'm Jorrit. I'm a researcher at the Dutch Applied Research Institute called TNO. And I'm a researcher on energy flexibility, and mainly focusing on energy flexibility behind the meter and protocols and optimizations for that. And that's right, the topic of today. We're talking about energy management behind the meter in a residential application. So we're talking about heat pumps, EV chargers, PV inverters, and just to make sure, I will be using the term energy management many times, so shortly introduce it. What I mean with it, it's the control of energy, smart appliances to deviate in terms of time and power from their baseline behavior. Controllability of large consumers and producers in homes. And in this talk, I'm also assuming that there is value in energy flexibility. Reasoning for that, in a nutshell, the amount of energy that households will consume will tremendously increase with the electrification of mobility and heating. And our grid simply doesn't have the capacity to transport that, but we also want to be able to follow the production with our demand, and therefore we need energy flexibility. A short overview of what you're currently seeing when it comes to energy management in the market. Because the nice thing, energy management is actually happening. It's beyond the proof of concept and pilot phase. Depends per country, of course, how big the uptake is, but it's actually happening. I was actually found very nice that there is this overview of the HEM system in Germany, the HEMS Finder, where you can already see quite some commercial products that actually are doing this. And we can categorize the energy management systems in 3 categories. And I think that when you would go through the list of the HEMS Finder, you could put all them in one of these categories. The first category is what I call appliance-based energy management, and there the manufacturer of the device offers extra services, energy flexibility services with his device. For example, to increase the self-consumption or to follow dynamic energy tariffs or limit the load on the connection. So those are then the benefits that the user will get when buying this product with an energy manager. From the same manufacturer as the one who produced the appliance. Another category of energy management is when the energy manager is implemented by an aggregator or an energy supplier. So that's then the party that has the balance responsibility on behalf of that consumer. And that allows the energy supplier also to reduce the energy prices for the owner of the energy flexible devices. Another proposition would be that the devices would consume electricity in times when there is a lot of green energy production. But we typically see that it's about the cost optimization for the end user. And then finally, the independent energy manager, that's the category where also the EMS of Nicolas falls into. And in that case, we have a third party that really has the role of managing the energy flexibility of the devices. And similar end user benefits are there, like increasing of the cell consumption, peak shaving use cases, but also the dynamic tariff optimization, of course. I now want to show a little bit of a roadmap, because we see that energy management is already happening, but it's still not very mature. And when we, for example, would create a graph where we show the number of flexible devices on premises, then now you find some households having an EV charger, some a heat pump, some maybe both, some have a home battery in combination with an inverter, but it's just 1 or 2, maybe 3 devices. And the number of end-user benefits or use cases are also still pretty limited. So it's typically dynamic energy tariff optimization, maybe grid connection limitation. So we currently still are in that phase with limited number of devices that have energy flexibility and also limited use cases. But when we will move in the future, more devices will become available in the residential setting that are flexible, that can be controlled. And it could also be that new use cases will be interesting for using energy flexibility. And we need to be ready for that. We need to be ready that the devices that are bought now, today, are ready to also serve the use cases of, well, 10 years later, that we currently maybe don't even know that they are existing. And we need to be ready for making sure that the devices are also capable of supporting those use cases. Because when we look, for example, to a very simple example of a combination where you have a heat pump and an EV charger, and you're having the use case where you want to try to avoid overloading the grid connection, and the devices would do that just with energy managers that are linked, tied to the device itself, then you could get a situation like this when there is an overload on the grid connection that's being detected by the heat pump and the EV charger. So they both will reduce their consumption in order to bring the total consumption on the grid connection down. So they both will do that, but then they see that there is actually still some capacity to reach the connection limit, so they will increase the consumption again. And that can start iterating, and then you have a wonderfully oscillating system, which you don't want. But another example what you can think of is when you have a home battery and an EV charger. If they both try to maximize the self-consumption and try to steer the grid consumption at 0, then a new uncontrollable load can become active. For example, you start brewing your coffee. Then the home battery detects there's grid consumption, so it starts discharging in order to bring the grid consumption to 0 back. But then the coffee is ready, and then the EV charger detects before the battery that there is actually injection from the grid. So then it will start discharging. And then what you have is that the battery will charge the EV charger while you actually would just want to use your solar production. So not what you want. And another example in which a combination of the use cases will fail is when you have, for example, a heat pump and an EV charger. And if they both try to optimize for the tariffs, then they will consume as much energy as possible when the prices are low. And that can result in an overloading of the grid connection capacity. So what goes wrong in all these 3 examples? You have different control strategy of different use cases that can be conflicting. And you have devices that are not aware of each other, that they are connected at the same grid connection. So that's why we think it's important that we have a central system in a home, a HEMS, because the HEMS can coordinate the energy flexibility of all the devices in the home, but is also a very nice decoupling point between anything in the home and anything outside of the home, because outside of the home you have also the steering signals. You can also call it energy flexibility activation mechanisms. And those are basically incentives from the outside world that make it interesting to do something with the energy flexibility of your devices. So yeah, crucial role for the HEMS, because it needs coordinated optimization over all devices. Also, a HEMS can do a local optimization, of course, and we're talking about the consumption of increase of self-consumption. And the HEMS also functions as a bridge between the technology before and behind the meter. There's one big catch here, because in order to create a scalable system, it's very important that the interfaces between the HEMS and the devices are standardized. And that's actually what the second part of my presentation will be about. That's the S2 story. Started more than 10 years ago, where we started initially with something we called the energy flexibility interface. Pretty descriptive and good name for what it actually is. But what we did in this interface is that we started looking at energy flexibility as an abstract concept. So we're not considering device-specific details like voltage cells in batteries or temperatures and heat buffers. We're just looking at a fill level in a buffer, for example. So that's a kind of an IT way of thinking towards energy flexibility and standardizing energy flexibility. We started standardization of this standard at SENS and NALEC in 2015. Since then, we did many field tests, we made many implementations, improved the standard, and took that into account in the standardization process. And then finally, after quite some years of meetings and testing, in 2022, the S2 standard was actually officially approved by all the standardization bodies in Europe, and got this wonderful number EN 50491-12-2. And since then, we've been working on creating an open source communication layer specification. So the standard itself is just a semantic standard, but in order to have interoperability, you also need to agree on, okay, what kind of serialization you're going to use, what kind of transport protocol you're going to use. So that's what we specified in the open source specification. We developed an S2 Python library, an S2 Rust library, and working on the adoption. So promoting the standard, because what currently is the big challenge is that there are actually devices and energy managers that are implementing this standard. So a little bit more about the S2 approach. I already mentioned it as an abstract concept for energy flexibility. So that means that we don't assume or make assumption on what kind of device provides the energy flexibility. Whether it's a heat pump that consumes electricity and converts that into heat, or whether you store electricity in a battery, it's both a form of storing energy. So in the standard, we also just talk about storage of energy. And we also don't assume the kind of optimization, and this is also a crucial feature of the S2 standard. You won't find any price signals or grid limits or whatever in the standard, because those things are things that the energy manager is concerned with and not the device. So we also made a very clear separation of concerns with the S2 standard between what the device should communicate to the SEM and what the SEM should do with that. And then the SEM can, of course, use external information like dynamic energy prices or congestion management signals from a DSO and whatnot, but that shouldn't go directly to the device. And another very important thing is the device always stays in control. So the device is responsible for making sure that safety limits are respected, that the user
comfort constraints are not violated, and the device just expresses to the energy manager, we call it the SEM in S2 terminologically, it expresses what kind of flexibility options it has, and then the SEM can choose from that and send control signals to the device, and it can actually ignore it if it needs to. So then a little bit more about how we're doing this. I already said S2 takes the approach of energy flexibility as an abstract concept, because we started looking at what kind of flexibility capabilities or flexibility patterns we see in residential applications, and then came up with these 8 capabilities, like power modulation, buffering, limiting consumption or production, storage of energy, pausing a task, choosing alternative power profile, switching energy source, or shifting a profile in time. And then we thought, okay, can we maybe cluster this or group this? And then actually that's possible. So we combined these 8 energy flexibility capabilities into 5 control types. And then with those 5 control types, we think we can cover all the sources of energy flexibility in residential applications. So if you now think, okay, cool, that sounds great, I want more, that's possible. I already said that the communication layer specification is open source on GitHub. So that's the first link. We have some documentation on how to use S2 and how to make implementations on EMSs and devices. And already mentioned also before in this presentation, we have some libraries that implement the communication specification and make it easier for developers to get started. And then finally, I want to address this. This is one of the latest things we are working on, is setting up an S2 alliance. And we also need you to help building this, because what we want is that exists in a community around S2, and we're currently kickstarting this alliance, and that will be the governance body for the S2 standard, organizing community events, meetups, making sure that there's some certification in place, and also working on the S2 roadmap, of course. So my colleague, Thomas van Dijk, is the one to contact if you are interested in being part of this this community and setting up, or well, joining this this alliance that we are setting up. Okay, so then it's now time for me to hand over the mic to Nicolas.
Thank you. I will only take a few minutes to talk a little bit about practical implementation experiences. There's 2 projects, both still ongoing. The first one soon ending, where we played a role as the EMS party in this S2 that's called a SEM, the Customer Energy Manager. So we took part of that side of the S2 equation, and various other parties implemented the Resource Manager. And I will very briefly go over what happened. First, this is also a picture from S2 that hasn't been mentioned so far. It just says that you have different, both of the sides, the CM and the RM, could potentially be on site locally or in the cloud, and you get different combinations, obviously. So you have cloud, local to cloud, or everything's local. The S2 protocol doesn't really tell you what to do. That as a clarification, because we had this first of the 2 projects where basically we do a local implementation. So here's a complicated architecture diagram of what has been made in that project. You'll see here, that's the one S2 part, right, the CM. That was what we were doing. Actually, in the context of FlexMatters, our LF Energy project, basically as a plugin to that. And we got the Resource Manager down here, both basically as two parts of the HEMS that exist locally. And then this HEMS was basically separated from that there's devices, and these devices were talking with Modbus, so that's a different architecture layer basically. We weren't concerned with that because they implemented a resource manager, so that's very convenient as a EMS party. Then you just talk to that RM manager and you don't have to deal with other things. So that's really the benefit here, right? We want to reduce the time it takes to build something. And everybody who is has played our role will know that you will come into new situations, and usually right now this term is coming up a lot. Modbus, for instance, are continuously new problems how you want to talk to some devices. So reducing this time is really great. But of course, when we have these early state pilots, that's not yet the case. But once we've built this and consolidated this, and we could get into a situation with S2 capable resources, then this really starts to fly. In this, a bit more about this project. Basically, yeah, it's a bit small, but there's a heat storage and a heat pump from two different startups from the Yes Delft cluster. So basically, this energy management problem was about smart heating and controlling the amount of heat in that heat buffer. So essentially, going back to the types, we are mostly concerned right now with the fill rate based control type. That would apply to a battery as well, or AVs, but also for heat storage. I guess it's actually the most complex type of them all. We actually also used Home Assistant in this local example to actually pull everything together there on site. So basically, you got a big open source mesh of things. The second project is not that old. It has been started a bit later. It's called the Kiflin project. It just happened to be, again, a smart heating project. So as you saw, maybe in my earlier talk, there's actually a lot of EV things we do, but in this case, we're dealing with smart heating again. Actually, here we had a more established OEM coming to join us and build their side of the S2 equation. Ito Dalderop is a quite established heat pump manufacturer in the Netherlands. And actually, we had to have a lot of interactions in this project because here, this is a local cloud version of making S2 possible. And there we went further than before because now we had to make it secure, or this was the goal here. I mean, here's a state diagram that I just pulled from the S2 documentation. It doesn't, of course, help you yet to really do this complete implementation. But together with Ito Dalderop, we figured out how we should do this, how we should do the interact via WebSockets and do the secure handshake and so forth. Yeah, a lot of that code that we wrote over there is also open source. I have to think in which repository that currently is. Part of it, I have been going into the S2 Python library that was linked earlier, but there's also a FlexMeasures S2 repository right now. So we are aiming to consolidate that much more. But it requires, of course, time in that project or funding in another project to make that accessible for more outside parties more easily. Lastly, in this project, we also, one work package is we actually make a tutorial, a script tutorial that shows how with FlexMeasures you create an S2 compatible HEMS from nothing. To close, basically with S2, we have created a new chicken and egg problem, of course. If both the chicken and the egg come together, we have a great feast. It will be good, but it's hard work at the beginning. And that hard work is currently being done by us and hopefully also by more people. There's a call in the Netherlands with funding by the ELAT organization to create open source connector libraries. And S2 is one of the protocols that they would fund over there. Matter is one, and EEBus is another one. So hopefully there will be much more activity. I think that most of the work has been on SEM part, and that the OEMs are the party that we have to pull much more harder on, and hopefully we'll get some more on board. Like Ito Dalderop is a great example, and I hope they set the way. Yeah, and lastly, this part here that I mentioned earlier for the Kiflin project was quite annoying to get a secure connection and figure all of these things out. But in the end, this is the maturity we need going onwards. Yeah, that's it for me. There's no thank you slide. Thank you.
Yeah, there's no thank you slide. Doesn't make us less grateful for you being still with us here at the end of the conference. Yeah, question.
Thanks for the nice presentation. I have a question. It's about S2 and EBUS protocol. Yes, EBUS is Germany protocol. Yes, it's widely used now. What about the difference between S2 and EBUS? Yes, the main difference.
Yeah. Main difference is that EEBus is mainly use case based. So it describes for all the applications of the energy flexibility what the device should do. So it specifies, for example, a dynamic tariff optimization, and then it will specify the signal that should be sent to the device that it can make an optimization based on prices. And in this way, you get a really much an intertwining of use case and the protocol. And that makes it less future-proof because we currently don't know what use cases will be relevant into 10, 20 years, for example. That's one of the big things. Another thing is maybe very practical, but the number of pages that the specification has is in case of S2 about 100. In case of EEBus, it's 600, and I think that the use case specifications will be then on top of that another, or the ship protocol will be on top of that another, I don't know how many 100 pages. So it's more complex. Yeah, I don't know if there's someone in the audience who has experience with implementing EEBus, but then a little bit. You tried?
Not personally, but my team.
You, Tim, what were the experiences? I'm very much interested to learn about it.
The first try took really a while. After a while, we got the first use case running, but getting all the shit took forever. And I think as soon as we had the first use case, we stopped. Like what the team told me, like the next use case would be easier.
Okay. Yeah.
We also looked at it, and I agree. Like you have to do a lot of foundation stuff first before you can get one single use case to work.
Yeah. The communication protocol ship is also being defined by the EEBus organization. You should use that when you want to communicate EEBus. Yeah.
We also heard about EBUS. I mean, basically, there's this EBUS e.V., the non-profit driving it. Then there's KEO, like the company trying to make money with EBUS licenses. And they don't stick to their own standard. That means the most dominant, it's the whatever library for that is not stick to the standard. So you yourself have to be bug compatible with that, and that's I think not a plenty situation. There are some people who, for that reason, gave up on EBUS, and they have even been one of the core authors. So at least that was one of the routes we tried, and then they gave up. So we tried another route.
Yeah. Yeah, so that's also from an implementation point of view. Also, one of the consequences of having a very complex situation based on use cases. Yeah.
And then having a very dominant single non-open source implementation is also not helpful.
Yeah, totally different route.
So again, right, the beauty of S2 is it's completely modular, and you're using it together with Home Assistant, and you could use it together with charging protocol.
Yeah.
Can I also ask, what do you think is the relationship to Matter? And because on one slide you show that it's stacked and you can combine it somehow.
Yeah.
And you also said that basically, so how do you see that?
Yeah. Yeah. So the idea here of this picture, but maybe just address your question directly. The relation to matter is that in principle you could communicate S2 over a low-level protocol to communicate to the devices, yeah, we think that S2 semantics are rich enough to express the characteristics of energy flexibility. So that's why you always need to make a translation from low-level device parameters to S2, and that's where these resource managers come into play. And then the actual communication to a device could still be happening via matter, where you say, okay, set this temperature for a heat pump, or put this light on 100%. But then the translation to the information that the SEM, so the energy manager, can use is done in S2.
For you, basically, S2 ends at the central node on site, but it doesn't go to the device level.
Yeah.
That's what I hear.
It goes up to the resource manager, and the resource manager connects to the device. Yeah, but it goes to the device level. Ideally, the resource manager is implemented on the device by the manufacturer, because then it has most knowledge and also control capabilities of the device.
It could be both. It could be like another tree under the resource manager, or it could be within the device. You support both, basically.
Yeah. Yeah, so you could use another protocol in between, or just have a native resource manager on your device. That's how I would formulate it. Yeah.
The idea is to have always different reference implementations, right? Or implementation on always different devices, and to create a library you can find. But there are challenges, for example, with the heat pump. If systems become more complex, and the heat pump has a different heat model that needs to be translated into the resource manager. It might not be that the resource manager of the heat pump A is directly installable on a heat pump of manufacturer B.
Yeah, there can be manufacturer-specific models, logic, or whatever in the resource manager for a specific heat pump. Yeah.
You want to make an average resource manager now?
At the moment, the average game plan is to support as many as possible outgoing connections, and then build the central logic to crunch all of that. And we have EBUS, we have Modbus, we have a bit of Sunspec, OpenADR is currently coming in, and Matters on the list, and S2 will be on the list as well. So that's why we're having to head around.
Yeah.
We have to find people helping with all that. We can't do that alone.
Yeah. Yeah, that sounds really interesting.
Tweeting what you're working on here, OpenADR, getting that to Everest. Need more partners. And we're definitely happy to help from the Pionix perspective on aligning, orchestrating, make sure the architecture works, that those things actually plug in. And then if even if there's a meta library or an S2 library, someone has to help to write the module, wrapper, rich code, whatever we call it around.
Yeah. So I think this would be very interesting to investigate this further, and also to do this as part of an S2 community where there are a couple of companies who want to contribute to these kind of things. We'll work together to realize it, and we're more than happy to help and do our best. Yeah. Other questions? Yeah.
You spent 50 years to push S2 to be a European standard. Do you have any plan to make it to be an ISO standard?
Almost. IEC. Yeah. 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 Correct. Yeah. So indeed,
it was a long process of standardizing at the European level. But yeah, the intention has always been to first do it on European level and then bring it to the IEC for a worldwide standard. Yeah.
So it's in progress.
Yeah, then that's in progress. Yeah, we are having. Yeah, that's a process which is ongoing currently. Yeah. Any other questions? Then thanks a lot for your attention and your presence at this wonderful summit. And hope to see you soon on another occasion, maybe next year, maybe already earlier. And looking forward to collaborate on S2 work.